Hi, in this example we're going to do number 73 from chapter 6 section 1 using Euler's method and to approximate a solution, and we're going to talk about the graph, and then we are going to talk about how we can use technology to do the calculations for us. Okay, maybe not in that order. Alright, so number 73, the derivative is equal to x plus y. They gave you that the initial conditions are x equals 0, then y equals 2. They wanted 10 steps and then a step size of 0.01. Or actually that's not correct. It's 0.1. So it's 0.1. Okay, so the n is going to go 0, 1, 2, 3 up to 10. All right, that's what this means. And then the increment is going to be 0.1. So we're going to start at 0, given that the initial condition was 0 here. And we're going to go 0.1, 0.2, 0.3. In other words, 0 plus this 0.1 is 0.1, 0.2, 0.3 on up. Okay, and now Euler's formula says that at 0, okay, it's 2. That was a given. Okay, so this first one is just going to be 2. But now when we calculate y sub 1, in other words, this one, 1, it's going to be equal to y sub 0, which we calculated to be 2, plus our step size, which is 0.1, times our derivative evaluated at x sub 0, y sub 0. So it's our derivative evaluated here. In other words, x being 0 plus y being 2. So 0 plus 2 is 2, so I'm going to take 2 plus 0.1, that comes from my h, again that was given, and then my derivative evaluated at 0, 2, okay, which is 2. So this ends up being 2 plus 0.2, which equals 2.2. So I've got my next number here. And now next, same idea, but now I'm going to take y sub 1. What was our y sub 1? Our y sub 1, look up here, this is where your subscript's coming from, was 2.2, so I'm going to plug that in, plus our step size, which is 0.1, times our derivative evaluated at 0.1 and 2.2. So in other words, 0.1 plus 2.2 is 2.3. Okay, and now when I work that out, I get 2.2 plus 0.23, and that is going to be equal to 2.43. So that's my next value here. And we can keep going. In the next step, I'm going to take 2.43, my last answer, plus 0.1. That's the same each time. And now I'm going to evaluate my function at 2, all right, or x equals 0.2 and y equals 2.43. And if I do that, my function is x plus y, so I'm just going to add those together. That's going to be 2.63. Doing that math, my answer ends up being 2.693. So that's my next value in my table. And we'll just go through one more. So y sub 4 would be 2.693 plus my h, which was 0.1, times my derivative evaluated at this point. 0.3 plus that, or in other words, 2.993. Okay, and if I do that math out, I get 2.992. Okay, so I have my values going in there. I'll just caution you that this work is tedious and there's lots of room to make mistakes. If you can, try to plug it into something like a spreadsheet. All right. So let's look at what I've done here. My spreadsheet automatically filled in the values for me. I'm just going to make that a little bigger so you can read them. Here are my n's that we talked about going 0 to 10. And then here are my x's going 0 to 1. And now for the first one, that was a given of 2, but let's look at my formula. My formula says to take C2, or my last answer. Looking back over here, that's just what your answer was before. Notice that step 1, we took the answer before. Step 2, we took the answer before. Okay, so it says take your original answer, add 0.1 times, again that was my h being 0.1, times, then I take C2 plus my x, okay, my y plus my x. Should have indicated these were my y's. Okay, so in the next step, it's going to be C2 plus B2. And then in the next one, it's going to be C3 plus B3. Obviously, I'm using that because my function was x plus y. if I had a different function, say 3x minus 2y, which is number 75, then obviously I would have programmed this different. This would have been 2 times x, being this value, b3, plus or minus 2 times c3. Okay, so keep that in mind. That's where that's coming from. But once I get that programmed in, the Excel will just do my calculations for me, and I can fill in my table automatically. Notice that for our first 4 steps, our answers match up. Okay, so I filled in the next 10. Now, again, I'm going to go to GeoGebra, which is my graphing of choice. And GeoGebra, if you go to options, or no, what is it, view, actually has a spreadsheet. So you can see I've filled in the first 4 numbers. Okay, and now through the magic of science, I filled in the rest of them. So I've got all my values filled in here. Okay, and now if I'm in the spreadsheet view, notice over here I can create a polyline. All right, that's what you want to do. And oh wait, I got to highlight my data and then do create polyline. And I'm just going to call it A and hit OK. Okay, and it didn't connect it. Let's try it one more time. Okay, and now notice it's given me my graph, all right, of that. Okay, so that's what the solution, or the Euler's method graph would look like. All right, I hope this helps. Again, the calculations are not that hard to do by hand. However, they get cumbersome if we have an n greater than 5, in my opinion. So on some of the homework, they're going to ask you to take it to n to 10 or whatever. So consider using a spreadsheet. If you want help with that, just let me know. So I hope this helps.